Assalamualaikum and hi everyone. I'm Ma'am Azlin and today I will lecture on the most fundamental part of physics. Any problems and inquiries regarding chapter 1, feel free to contact me at this number. Okay guys, let's get started. In chapter 1, the topics are physical quantities and unit, dimensional analysis and unit conversion. What is physical quantity? Physical quantity is a quantity that can be measured and can be expressed as the combination of a magnitude and a unit. There are two types of physical quantities. For the first one is base quantities. Base quantities are the quantities that cannot be defined in any other physical quantities or known as fundamental physical quantities. There are 7 basic quantities that you have to memorize. As an example, the SI base unit for length is meter and the symbol is M. The SI base unit for current is ampere and the unit is capital A. Next, the derived quantities. Derived quantities are the quantities that can be obtained and expressed in terms of base quantities. As an example, acceleration is derived from velocity divided by time, and at the same time velocity is derived from displacement divided by time. Another example is force. Force is equals to mass multiplied with acceleration. The derived unit is Newton and the symbol is capital N, while the SI unit is kg, meter per second square. Now we go to the dimensional analysis. Remember to put the square bracket at each particular physical quantity in the equation whenever you want to use dimensional analysis. Table shows 5 common basic quantities together with their dimension and symbol. As an example, we use capital letter to represent dimension for each basic quantity. Dimension for length is capital L. Now you have to memorize the unit for dimension L is meter. Dimension for mass is capital M and capital M always represent the unit of kg. Another thing you have to memorize is that the dimension of any number or dimension of any constant is always equal to 1. Now, there are 3 purposes of using dimensional analysis. For the first one, to show the dimension of physical quantities. Now we go to the example. Consider the equation T equals to 2 pi sed m over k, where m is a mass and t is a time. What is the dimension and unit of k? Now, you have to change the subject from t to k. Whenever you change the subject, then you have the equation k equals to 4 pi square m per t square. Now, at this step, you have to do dimensional analysis. Please put the square bracket at each physical quantity and numbers on the left and also on the right hand side of the equation. Therefore, the dimension for 4 pi square or dimension of a number is equal to 1. Dimension for mass is capital M. Dimension for time or period is equal to t. Therefore, the dimension for k is m per t square. Now, dimension for m always represent kg. Dimension for t always represent second. So, the unit for k is kg per second square. Now we go to the second purpose of using dimensional analysis is to check the homogeneity or correctness of an equation. Let's go to the example. Show the homogeneity of the dimension for the following equation. P equals to rho GH, where P is pressure, rho is density, G is gravitational acceleration, and H is height. There is a technique to check the correctness of an equation. Let's say we have an example, V squared equals to U squared plus 2AS. Remember, to state whether the equation is homogeneous or not, you must remember each terms on the left hand side and each terms on the right hand side must have the same dimensions or equal dimensions. Therefore, the dimension is homogeneous. As for the first step, you have to state the dimension on the left hand side of the equation. On the left hand side, we have pressure, which is given the formula is force divided by area. Force is mass multiplied with acceleration. Alright, so dimension for mass is m, dimension for acceleration is L per t square, and dimension of area is L square. Therefore, the dimension for pressure is m per L per t square. Now we go to the right hand side of the equation. Okay, first we have density. So density, the formula for density is mass divided by volume. So dimension for mass is m, dimension for volume is L cube. Therefore, the dimension for density is m per L cube. Now you have to state the dimension on each side of the equation. On the left hand side is m per L per t square. On the right hand side, you have to multiply each of the dimension for each particular physical quantity. So we have m per L cube multiply with L per t squared multiply with L. So we get m per L per t square. So as what we can see from the slide, both dimension on the left hand side and the right hand side shows the equal dimension. Therefore, the dimension of this equation is homogeneous. Now we go to the third function of dimensional analysis, is to establish relationship between related physical quantities. So we go to the example. The period of oscillation of a simple pendulum depends on length and acceleration due to gravity. Let us derive the relation between T, L and G. So whenever we get this kind of problem, it means that we have to write down the solution. So, you have to write down the equation first. So the equation will be T is directly proportional to the L and G together with their respective power. Therefore, T equals to K, which is constant, times with L to the power of X and G to the power of Y. That's what you should do. You have to find the dimension on the left hand side. On the left hand side, the dimension for period is T. Now, on the right hand side. On the right hand side, you have to find the dimension of each particular quantity. For dimension for a constant, K is equals to 1. Dimension for length is equal to L to the power of X. Dimension for gravitational acceleration is equal to L per t square to the power of Y. Now you have to expand the equation, then you get the dimension for right hand side is L to the power of X plus Y and T to the power of negative 2Y. Now you have to write down the dimension at both sides of the equation. So we get T equals to L to the power of X plus Y and then T to the power of negative 2Y. Now, to write down this equation, you have to find the values of X and Y. So then what you should do? You have to write down the power at each particular dimension. For dimension T, on the left hand side, the power is 1. On the right hand side, the power is negative 2y. Therefore, y is equal to negative 1 over 2. Dimension L on the left hand side, there is no dimension for L on the left hand side, so it is 0. On the right hand side, it is X plus Y. So you insert the value of Y, then you get the X equal to 1 over 2. Okay, with this value, you insert into the equation above, then you get T equals to K L or 1 over 2 and g negative 1 over 2. Therefore, the equation will be, then you establish the equation is t equals to k sert L over g. Alright, next we go to the unit conversion. The table shows the conversion factor for each particular physical quantity for length, mass, volume, and time. For length, the conversion factor from inch to cm is 1 cm equals to 2.54 cm. 1 mile equals to 1.609 kilometer. And the rest you can refer from this figure, from this table. Alright, now we go to the example. I have two examples. Now we go to the first one. Okay, 15 millimeter square to convert into meter square. Okay, to solve this kind of problem, you have to memorize the prefix and the multiplying factor and together with their symbol. As an example, nano multiplying factor is 10 to the power negative 9 and the symbol is n. So what you should do with this equation, you write down any numbers that are given. So you have unit prefix, then you have prefix and also unit. Okay, we have power here, power 2. So you have to multiply the prefix with power 2 and also meter, you have to multiply with their power 2. Alright, so meaning that 15 times with milli. Milli stands for 10 to the power of negative 3. Then you multiply with to the power of 2. Alright, meter to the power of 2. Meter square. Alright, so then when you solve, you simplify, then you get the answer is 1.5 times 10 to the power of negative 5 meter square. For example 2, you can do by your own and check with your own lecturers. So that's all from me. Thank you. Once again, if you have any inquiries, please feel free to contact me. Thank you. Assalamualaikum.